we talked about the log function, and then because this is a logarithm, the logarithmic function is so important. And for the log, which is the new operation, and there are several properties, and we're going to focus on that in today's session. So properties of logarithms. Logarithms. Okay, what does that mean? And first of all, we know that we can rewrite like a log as the other form is going to be the exponential, right? Okay, so let's review some properties of exponents. Okay, several of them. B to the m multiplied by b to the n equals b to the m plus n. Because basically b to the m means b times b times b multiplied by itself m times. And here is n times. If you multiply them together, then there will be m plus n that many times, right? So the other one is b to the m over b to the n, and that will be b to the m minus n. That's a second property. All right. Now the third one is a power of power. So b to the m and to the nth. So which means b multiply by itself m times, and then repeat that n times. So at the end, you should have this many b all together. Okay. Now similarly, very similar, and then we look at the property of logarithms. It's going to look like this. Pay attention to here. Okay, so this is the power and a power and a power and a power. Then I get this. I get a log base the base m plus log base n, which is log b m times n. So if you want to take a log of a product, which means you need to take you can take the log of the first one plus the log of the second one. Okay, and this one log b to the m minus log b to the n, which is going to be log b m over n. All right, and then the last one is log b m to the power. I can bring the power to the front, and then I go b to the m. I don't know how much you can remember this, but there is a lot of ways to prove the equivalency of these two sides. So I will not ask you to remember how to do it, but I do ask you to know all the properties. And then see, here is a log plus log with the same base. Log plus log is the log of product. Log minus log is the log of same base, log of the quotient. And then log of log of a guy to a power, and then we can just bring the power in front of this log. So from here to here, we call this is condensing. From right to the left, we call that expanding. Expanding, get more terms, isn't it? Okay. It is hard. I don't know how much you can remember, but anyway, you can take a note. You can take a note before you go to my next slides or go to my next page. My next page, expand. The following. The first one, log 4, 7 times 5. Here's multiply. Okay, expand. Log product, which means log 4, 7 plus log 4, 5. Okay, and the next one, log 10x. Hey, if I don't see the base here, which means the base is 10, right? And here's the product. So I get a log 10 plus log x. All right, what is log 10? Log 10, 10. The base is 10 here. So if here's a base, here's a base, log of b, which is 1. So when you simplify, you get log 1 plus log x. Okay, next one, log 7, 19 over x. Log of a quotient, so that would be the log 7, 19 minus log same base x. Continue. ln, you know what ln is? ln means log base to e, and e to the third over 7. This is the division, so I'm going to do log e to the third top minus log 7. And what is this? Log of b, here is e, right? The base is e, e3. So I bring this a 3 in front, log e, which is 1. So that's a 3 minus ln 7. Or if you remember, we have this. We have a b to the x equals x. Do you remember? Okay, that was the simple property. Okay, next one. Log base 5, 7 to the 4th. And I bring this 4 to front, which is a 4 times log 5, 7. Okay, more. ln square root of x, and I write this square root as the power of 1/2, so I can just bring this to front, and that will be 1/2 ln x. Okay, the last one, I ask you to do log 4x to the 5th power. First of all, the power, I can bring that to front, so I get a 5 log 4x, and the log of a product, which will be 5 times log 4 plus log x. I finished my expansion work. Okay. All right, now let's work on something more difficult or more complicated. Here, log b x squared times square root of y. This is a log of a product, so we get a log b x squared plus log b square root of y. And I bring this 2 to front, so I get a 2 log b x. And this square root of y, that is y to the 1/2 power. So this 1/2 go to front, so that will be 1/2 log b y. So starting from here to here is called expansion. One more, so I do log 6 cube root of x over 36x to the 4th. So first of all, we do log a quotient, so log the top minus the log bottom. So log 6, and the top is the cube root of x minus log 6, 36x to the 4th. Okay? And then I rewrite this as x to 1/3 minus, okay, after this minus, you see that's a log of a product, so that will be log 6, 36 plus log 6 x of 4th. So we're changing this product into the sum of two logs. So this one, I bring this 1/3 to front. So that would be log based 6x. And 36 is a 6 square, right? So here's a 6 square. Log 6 square, which is 2. Plus, and then this guy, I'm going to bring the 4 in front, so I have a 4 log 6x. Is that y. Is that y? Yeah, I'm sorry, here should be y. Oh, no wonder. Okay, here's y and here's y. Sorry. And then I get a 1/3 log 6x minus 2 plus 4 log 6y. That's my answer. I expand the whole thing from here. So that's called expansion. Okay, not bad, right? So after I do the expansion, I will show you how to do condensing. I want you to condense. Condense the following. Okay, the first one, log base 4, 2 plus log 4, 32. Log plus log is the log of a product. So there will be 2 times 32, which is log 4, 64. But not done yet. I know 64 is 4 to the third. It's 4 cubed. So this is log 4, 4 to the third, and that is a 3. Because here is the same thing. So let's go. This is the first one for condensing. Second one, log 4x minus 3 minus log x. The log minus log, which will be log. This minus becomes fraction. So here it's a 4x minus 3. I don't need to worry about the base because the base is 10. Okay, and the next one, 1/2 log x, again base 10, right? Plus 4 log x minus 1. This 1/2, when we do condensing, it moves to the top of the top of that x. So that will be log x 1/2. And then here is plus, so we change that into multiplication. And the next one is x minus 1, and this 4 moves up here to the 4. Okay, so if you like, you can put them in the bracket. That means I'm done with this. Of course, if you want, you can change this into square root, but it's not necessary. All right, next one is a 3 ln x plus 7 minus ln x. So first of all, I bring this 3 on top, so that will be log or ln x plus 7 to the third minus ln x. So ln minus ln, which is ln x plus 7 to the third. Okay. Next one, 4 log b x minus 2 log b 6 minus 1/2 log b y. All right, now this is log b. I bring this 4 up, so it's x to the 4th. And a minus log b. I bring this 2 up, so it's a 6 squared. And a minus log b. I bring this 1/2 to the exponent of 2. So this minus this log minus log, which is the log b, x to the 4th over 6 squared, or you can put 36, minus another log. So log minus log means division. Okay, so that means the log b, x to the 4th over 6 squared divided by that, or means multiplied by 1 over y square root. Okay, and of course, if you like, you can write this way. You can write log b. The top is x to the 4th. The bottom is a 36, 6 squared. And then this one, you can put a square root of y if you like. Okay. So you are condensing. You get a lot of logs and the end you give me the one answer that is only 1 log. So those are the important properties of the log. And there's one more thing. This one is very important. It's very unique because we don't have that in the exponents. It's called a change of base property. Change of base property. What it says is this: log b m equals log. We can change the base to be a, whatever, okay? And the bottom is log a b. Did you see that? We changed the base. The base now is from b to a, and then here's m, here's a b. And we can prove it. Do you know how to prove it? Here. Let log b to the m, big M, equals little m, and which means b to the little m is big M, right? Okay, and then we take a log based on a on both sides. Okay, so we take log a b to the little m equals, that will be log a big M. See what I'm doing? I just add this little log a, or take the log based on a on both sides, and I bring this over. So m log b equals log big M. And remember what is m? Here. You see that? So this m, that's log b m multiplied by log AB equals log AM. Okay, and then I divided by this guy both sides. So I got log B M will equal to, change the base to a, M over the log base to a little b. So I proved it. I am not asking you to prove this. You don't have to. But I want you to know that if you have the log B M, if you want to change that base to be base 10, then you're going to have log M over log B. Or if you change that into another one with the base E, you're going to have ln M over ln B. Why? Why you want to do that? This is so useful because in the calculator, hold on, let me show you the calculator. Okay, here is the calculator. Did you see the log here? Here is a log y. Did you see that? And it's interesting that they also have the log base 2. And then there is another one is ln. Let me see, it could be here. You see this? ln log base 10. Do you see that? So the calculator can only help you to calculate the log with particular base. So without changing base, if I give you the base b is 5, the calculator cannot do it. Okay, so that is why. All right, now why? Let me show you. If I ask you to calculate log 5 of 140, we change the base to be e. So that will be ln 140 divided by ln 5. Come on, we can do that. Okay, so you choose ln. Do you see that? So 140 ln divided by 5 ln. So that is ln 140 divided by ln 5. And the answer is 3.07. We keep 2 decimal places. I think that'll be good enough. Okay. Otherwise, it's hard to do that without changing base formula. Change of base formula, you cannot do it. And the change the base, then we change it to the base of either 10 or e, then we can do it. So let's try if change that into log 140 over log 5 to see whether we get the same answer, okay? 140, do you see log 10? Okay, divided by 5 log 10 equal. We get exactly the same answer, 3.07. All right, now think about what we have learned in this section. We learned more properties and more properties of the log, and we learned how to condense, we learned how to expand, and we learned finally we learned the change of a base property. This is very important. Okay, so that's all for the properties of the log.